We're now going to use the eye model to look at aberrations through a field or through depth. So here we're looking at the aberration coma that we've put on the cornea of the eye. So we're looking at the image plane right here. So some aberration has been put on the cornea. Light has traveled into the eye. Here's a cross-section of that coma and an isometric view. And the display once again. So in order to do this, I go and load my coma aberration. So I have a saved settings file. Say OK. Alright, so I've got a coherent mode as well now, so I have that box checked. I've got an anterior corneal Zernike pupil diameter of 5.7, which is the same as the pupil of the iris. So I'm going to deform over that cornea with some coma. Right, so I click OK, and I get another screen related to my AZ basic geometry, my AZ lens model. Here I've got my 3D PSF and number of slices through focus set. So now that I have numbers here, that will invoke that feature. So I'm going to look through depth of 0.2 millimeters, and then I'm going to slice up that depth into a volume and look at the field of the light as it travels into the retina. So click OK. And then I get my Zernike deformation screen, and I've got just 0.01 microns of Zernike coma on there. So I click OK, and the trace begins. So now we have our volume of a field of that coma. We're looking at depth of field, or depth of focus, if you will, to the retina. And I can look at various planes, and when I click on them, I see their location and what axis they're on and what axis they're relevant to. I can hide different planes, and I'm going to hide a few here so I can look at that aberration a little more. I can also move the planes through that depth using the 8 and 9 keys on my keypad. So I can move through focus and see how that aberration changes. Let me hide this one. I can do that with any of these planes. If I just click on them, I can move them in the respective direction. So we see that chromatic aberration maintained through the field. Here is the aberration directly on the best focus of the retina.